All right, pre-algebra class, today we're going to talk about section 8.3 in your book, Graphing Linear Relations. Today's objective is to find solutions for relations with two variables and to graph solutions. So first off, what is a linear equation? So the equations we'll be graphing have two variables, x and y. And we've been graphing these already using IXL, but we're going to use paper and pencil, or like a worksheet and a graph to graph them today rather than the computer. So for example, y equals -2/3 multiplied by x plus 4. A solution to the equation is any ordered pair x and y that make the equation true. The ordered pair 3, 2 is a solution since, watch what happens. So we take x equals 3, we plug it in for x. We take y equals 2, we plug it in for y, and we simplify. All right, so well, a negative times a positive is a negative. 3 divided by 3 is 1, so that becomes -2. -2 plus 4 is 2, right? So that makes that equation true. If we were to plot all the solutions to this equation, the ordered pairs would form a line. Now, we can't plot all the solutions because there's an infinite number of solutions to that equation. But we can pick, if you pick two, you can plot both of those and connect the dots and it forms a line. If you want to plot 3 or 4 or 5, and you can see here in this graph, I have 1, 2, 3, 4, 5 points plotted and the dots were connected. So 2 is enough to make a line, but you're welcome to plot more. So if we were to plot all solutions to this equation, the ordered pairs would form a line. This is a linear equation because the graph is a line. So line, linear, an equation because this is an equation. So that is the equation of this line over here to the right. Also, an equation with two variables has an infinite number of solutions. So some vocabulary here. A solution of an equation is two variables, x and y, is an ordered pair that make the equation true. So an x value and a corresponding y value that make that equation true, like we just saw on the previous slide. The graph of an equation in x and y is the set of all points, x and y, that are solutions to the equation. So remember, there's an infinite number of solutions to a line, right? There's an infinite number of points on a line because the line goes on forever. But the graph represents all of those solutions. So we don't have to put dots for the infinite solutions, not that it's even possible, but the line represents all of those solutions. And of course, the graph of a linear equation forms a line. So we are graphing lines today, kids. So let's talk about solutions. Here we have an equation. Which order pairs is a solution to y equals 0.5 times x. So we have 10, 20, 8, 4, 300, 600. So think about what we're going to do. We had an IXL assignment on this U.8. So we take our y value, we plug that in for y. We take our x value, we plug that in for x. So 20 equals 0.5 multiplied by, instead of x, you plug in 10. Again, y comes out, the y coordinate goes in its place. X comes out, the x coordinate goes in its place. And now we ask ourselves, is this equation true? Well, half of 10 is 5. So is 20 equal to 5? No, it's not. So this is not a solution to the equation y equals 0.5 times x. How about 8, 4? Again, 8 goes in for x, 4 goes in for y. So 4 goes in for y. 0.5 multiplied by x, which is 8. Okay, half of 8 is 4. So is 4 equal to 4? Yes, it is. So that is a solution to the equation y equals 0.5 times x. How about 300, 600? Again, 300 goes in for x, 600 goes in for y. So 600 equals 0.5, and instead of x, we plug in a 300. Okay, so 600 equals, half of 300 is 150. So these are not equal to each other. So this is not a solution. So the only solution out of those three was the ordered pair 8, 4. How about you try this one on your own? Which ordered pairs is a solution to this equation? X minus 3y equals -7. And here are the ordered pairs right there. So try that one out on your own. Which of these ordered pairs is a solution to that equation? Pause the video now and try this problem out. Okay, so again, for each of these, we take our x coordinate, we plug it in for x, we take our y coordinate, we plug it in for y, and we simplify the equation. You have to remember your order of operations here, PEMDAS. If you are forgetting PEMDAS, let me know. I can give you a review assignment to get you up to speed, but that's that's stuff you probably learned before Marist, and I know we learned it during term 1. So if you're having a hard time with PEMDAS, you have to get caught up. That's going to be a problem. So anyway, we plug in 2 for x, 4 for y, and we get -10 equals -7, which of course those are not equal, so this is not a solution, 2, 4. Same thing for 2 and -1. We plug in 2 for x, -1 for y. We simplify and we get 5 is equal to -7, which those are not equal to each other. Same thing for 2, 3. We plug in 2 for x, 3 for y. All right, check out what happens here. We multiply first. That would be 3 times 3, so it's 2 minus 9 equals -7, and 2 minus 9 is -7, so -7 equals -7. That is a true equation, so 2, 3 is a solution. Same thing for the last order pair, -1, 2, -1 goes in for x, 2 goes in for y. 3 times 2, we have to multiply before we subtract, so we get 6. -1 minus 6, we get -7. -7 equals -7. That is also a solution. Now, when we say solution, these two that are solutions, the ones that I have boxed here, these would be on the line. That's what that means. So when you plot these 2 points, connect the dots, those are on the line. These two that are not solutions, these are not on the line. So if you wanted to, you could graph this line now. You would plot 2, 3, you would plot -1, 2, connect those 2 dots, and that is your line. And you would notice that 2, 4, and 2, -1 are not on that line, which makes sense because when this line passes through x equals 2, it's at 2, 3. It's not at 2, -1, and it's not at 2, 4. It's at 2, 3 when it passes through x equals 2. There's not just one way to do this, but here are some steps you might want to take if you're having a hard time with this. Rewrite this so that we have solve for y. So rewrite the equation in function form by solving for y. That means you're isolating y. Choose a few values for x and make a table of values. What values for x? Well, starting with x equals 0 is usually a good one. Not always, but usually that's a pretty easy one to work with. And then you can choose any other values you want to. There is no limitation on what x can be. Number 3. Use the values in the table to write coordinates, write ordered pairs, right? We're creating ordered pairs out of a table of values. And number 4, we're going to plot the points on a graph. And then finally, connect your points. So what we did was, in the previous slide, which I can't go back, but we found ordered pairs that are on the graph, and we could then plot them. The difference being you sometimes have to choose your own x values, which you've done before in IXL U.8. So let's try an example now. You'll need to draw a graph on a piece of paper, but find 4 solutions for the equation y equals 3x plus 2. Right, the solutions is ordered pairs. All right, pause the video now. Find 4 solutions and then plot them and connect the dots. If you get stuck, unpause the video and I will work slowly through this, and you can pause the video along the way and kind of work this on your own as well. Okay, so here's what I did. I created a table. First column is my x coordinate. Second column is my equation. My third column is the output, the y coordinate that I'm going to get after I substitute in x. So remember, you can choose any values for x that you want to. I chose x equals 0. That's usually pretty easy to work with. So y equals, we're going to find y, 3. Instead of x, I plug in 0 plus 2. Well, 3 times 0 is 0, plus 2 is 2. So I've got an ordered pair. X is 0, y is 2. So that's right there on my graph. Okay? Pause the video now. Follow those steps if you needed help. If you didn't need help, then let's keep going. Okay, next I chose x equals 2. Why did I choose x equals 2? I had to choose something. y equals 3 times 2, which is 6, plus 2 is 8. So I get the ordered pair 2, 8. And you'll see that plotted here to the right 2 and up 1, 2, 3, 4, 5, 6, 7, 8. There, that red dot where my cursor is, that is the point 2, 8. Next, I chose x equals negative 2. Well, I wanted to go to the other side of the original point that I plotted. Again, it does not matter. As long as you get at least 2 points, you can graph your line. You probably did not choose the same points I did for x. That is totally okay. So y equals 3 times negative 2, that's going to be negative 6, plus 2 is negative 4. So when x is negative 2, y is negative 4. So the point 1, 2, that's negative 2 right there. Negative 1, 2, 3, 4. There is the point negative 2, negative 4. Now watch this. I'm going to choose x equals 10. 3 times 10 is 30 plus 2. I get 32. 32. So the order pair 10, 32. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then up 32. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What do you notice? I run out of squares, don't I? Right? So sometimes this happens. Sometimes you have a point and you fall off the graph. Oh no, it's okay. Just don't plot that point. You can't plot 1032 on this graph. You need your graph to go out further. So I would probably choose a different point, like, I don't know, x equals 3, right? So y equals 3 times, instead of x, I sub in a 3, plus 2. 3 times 3 is 9. 9 plus 2 is 11. So we get the ordered pair 3, 11. 1, 2, 3, and then up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right there. Now let's connect the dots. Now do your best to draw a straight line. It's tough to do on the computer sometimes. Something like that. Okay, now here's the deal. If you are connecting the dots and you're doing a good job connecting the dots, and your line curves, here's what happened. You made a mistake. One of your points, maybe more than one of your points, is off. These lines should be perfectly straight like this. They should not curve. Now, sometimes you're not good at drawing a line and it curves because of that. That's different. If it curves because your point is in the wrong spot, and if you did a perfect job connecting the dots and it curves, like for example, let's say you had like this point over here, all right? And then you connected the dots and your line did this. Well, I did a good job connecting my dots. That's not the error. The error is in that point right there. This is actually not on the line. What happened here is you made an algebraic mistake in this table. So just know if your line curves, do not move on. You made a mistake. Find your mistake and fix it. All right, very good. Let's try one more here. Find 4 solutions for the equation y equals negative 2x plus 1. Like we just did, please create a table. So I would advise you to create the table like I did, x, and then in the center here we have y equals negative 2x plus 1. Excuse me, let's go back. Negative 2x plus 1. And then you're going to have your y column as well. So I would advise you to do it this way, but make sure you are writing this out and actually graphing this. All right, pause the video now and find 4 solutions for that equation. Here are the points I chose. X equals 0, x equals 2, x equals 4, x equals negative 2. These are not the only values for x you need to choose. You have unlimited possibilities other than falling off the graph. So you probably did not choose the same x coordinates as me, and that is okay. Y equals negative 2 times, instead of x, I sub in a 0. That becomes 0 plus 1. So we get y equals 1. So we have the ordered pair. Let me write these ordered pairs out. 0, 1. And here you see the ordered pair. 0, 1 right there. Next, I subbed in x equals 2. Y equals negative 2. Instead of x, I sub in a 2 plus 1. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. So we get the ordered pair 2, negative 3. So 2, negative 1, 2, 3 right there. 2, negative 3. I then subbed in x equals 4. Y equals -2. Instead of x, I sub in a 4. We get -8 plus 1 is -7. So 4, -7 is right down here. And then finally, I chose x equals -2. Y equals -2 times, instead of x, I sub in a -2. That gives me 4. 4 plus 1 is 5. So -2, 5 is this point up here. -2, 5. All right, now we connect the dots. Remember, if your line curves, it's because you made a mistake with one of your points. You have an ordered pair that is off. So my last two ordered pairs were 4, -7, and -2, 5. Let's say you have a problem like this where y is not isolated. If you want to adjust the equation around so y is isolated, so we can subtract 2x from both sides, right? That's going to give us y equals -2x plus 10. It's probably easier to work with the equation once y is isolated. So I would encourage you to do that if you come across a problem like this. We came across this in IXL. Let's say we have a fraction in here, like 2/3. So y equals 2/3 x minus 2. That's going to give us a y. So create your table and see if you can't remember how to do this from IXL U.8. And if you can't, unpause the video and you'll see me working it. And if you can remember it, check back in and see if you did it right. Pause the video now. All right, I'm going to start with x equals 0 because when you multiply by 0, that makes things a little bit simpler. So y equals 2/3. Instead of x, I plug in a 0. That's going to become 0 minus 2. So I get -2 for y. So we have an ordered pair, 0, -2. 0, -2 is right there. All right, now here's the tough part. If we want to come up with at least one more point, notice we're going to be dividing by 3. You might be saying, well, we're multiplying by 2/3. Well, yeah, multiplying by 2/3 is multiplying by 2 and dividing by 3. So we're going to be dividing by 3. If we're dividing by 3, we want to choose multiples of 3. So think about the multiples of 3. 3, 6, 9, 12. So I'll choose 3 and I'll choose 6. So y equals, pause the video now and work this out on your own if you haven't already done this, but 2/3 multiplied by 3 minus 2. Now, 3 divided by 3 is 1. 1 times 2 is 2. 2 minus 2 is 0. I'm going to do that again. I'll do it another way. How about this? 3 times 2 is 6. 6 divided by 3 is 2. 2 minus 2 is 0. So either way, you get 3, 0. 1, 2, 3, 0 is right there. Okay. 6, y equals 2/3. Again, I chose 6 because it's a multiple of my denominator, which is 3. It's going to make my life a little bit easier. I don't have to work with fractions. 6 divided by 3 is 2. 2 times 2 is 4. 4 minus 2 is 2. So we get the ordered pair 6, 2. 1, 2, 3, 4, 5, 6. 1, 2, right there. All right, this is where you are likely to make a mistake and your line is curved. So on a problem like this, if your line is curved, make sure you go back and check your math to make sure you didn't make a mistake. So we have the ordered pair 0, -2, 3, 0, and 6, 2. Let's say we have the equation x equals 4. Well, we can choose ordered pairs where x is 4, like 4, 0, or 4, 2, or 4, 5. All of these are on the line x equals 4, right? These are our x coordinates here. The only rule is x has to equal 4, right? So 1, 2, 3, 4 right there. There is 4, 0. This is 4, 2. 1, 2, 2, 3, 4, 5. There's 4, 5. Oh no, what happened? Right there. Okay. And now we connect the dots. And what do you notice about this line? This is a vertical line. So when you have x equals something, it's going to be a vertical line. Okay. Well, if x equals something is a vertical line, what do you think y equals something is? Well, if y equals -2 is our line, all you have to do is choose values for y that are -2. So 0, -2, 2, -2, 5, -2. As long as y is -2, it's going to be on this graph. So 0, -2, 1, 2, right there. My pen keeps messing up. All right, I'm going to plot these points. I'll be right back. All right, so I've plotted my order pairs, and as we connect the dots, you'll see we have a horizontal line there. So that is the line y equals -2. So y equals something is always going to be a horizontal line. Okay. All right, and the last thing I'm going to share with you is this. An equation will always be linear if x and y are to the power of 1. So for example, y equals 4x plus 2. That's y to the power of 1, x to the power of 1. That is linear. It's going to be a line when you graph it. Y equals 3x to the power of 5. This is not to the power of 1, so this is not linear. So there you go. Hope you guys have a great day. Good luck on the assignment.